Let's take a look at an elastic collision. That's one where momentum and kinetic energy is conserved. And in this one we have a steel ball that's hanging from a string as a pendulum, and it's held horizontally, allowed to swing down, and it collides with a stationary block, and we are told this is an elastic collision. We want to figure out the final velocity of the steel ball and the final velocity of the block. This is from Chapter 10 in Halliday, Resnick, Walker, 5th edition. It's number 34 on page 234. And so we're neglecting friction on the surface, or we're solving for this immediately after the collision before friction has had a chance to change the momentum of the objects. The mass of the steel ball is 0.5 kilogram. The mass of the block is 2.5 kilograms, and the initial velocity of the block is 0. And so I'm using S for steel ball and B for block. And the first thing we need to do is figure out how fast the steel ball is going before the collision, and for that we just use conservation of energy. And so the steel ball swings down and hits the block. The potential energy it starts with equals the kinetic energy at the bottom, assuming we say the bottom is 0 height. And solving for the initial velocity of the steel ball, it comes out to 3.7 meters per second. And so now that we know that, we're ready to apply conservation of momentum to this problem and conservation of kinetic energy. So the steel ball collides with the block with an initial speed of 3.7. Find the final speeds immediately after the collision. And so elastic collision, momentum and kinetic energy is conserved, but always do momentum first. Momentum is always conserved, so if this was not an elastic collision, this equation would still apply. And so the initial momentum is all in the steel ball. The block is not moving initially, and the final momentum is shared by them, and so it's the mass of each times their unknown velocity. So if we substitute in our masses and our known initial velocity of the steel ball, we get an equation with two unknowns. And so we have V steel ball final and V block final as our unknowns. So we need one more equation, and since we're told it's an elastic collision, we can also say the kinetic energy is conserved. Some people call this a perfectly elastic collision. We are just defining elastic collision to mean kinetic energy is conserved as well. And so the initial kinetic energy is all in the steel ball, 1/2 m v initial squared, and the final is shared between them, the steel ball's kinetic energy and the block's kinetic energy. We can do some simplification, and we can substitute in the masses, and eventually we reach a point where we have two equations and two unknowns. And so we have our momentum equation up here and our kinetic energy equation here, and so the rest is just algebra. So my advice is to take the simpler equation, the momentum equation, solve it for one of the unknowns, and substitute that into one of the unknowns in the kinetic energy equation. And so arbitrarily, I'm going to solve for V steel ball final with the momentum equation and substitute that into here, and then solve for the block's final velocity. And here's a little hint that will help you. If one object is stationary before the collision, solve for its final velocity first, and you won't get a quadratic. And so one answer is always the velocity of the object without a collision, and so since that is 0 for the block, it will eliminate having the quadratic, which isn't a big deal either way. And so here are two equations. This is the kinetic energy equation from above, and I've taken the momentum equation and solved it for the steel ball's final velocity. And notice up here it's the square of the steel ball's velocity, so I'm going to square this out first. And so I square 3.7 minus 5 VBF, and I get this. You should know how to do that. And so that gets substituted into here. And so it's going to be kind of complex, but take your time, work it out, and you end up with an equation with just VB final in it. And so if you work that out, you get VB final is 1.23 meters per second. And if you substitute that into your momentum equation, you get V steel ball final is negative 2.45. So it will bounce backwards after it hits the block. And so give this one a try. Chances are you won't have to go through all this algebra if this was on a test, but you should be able to set up the equations. Don't get too concerned about getting lost in the algebra.